An interesting note on limits is that we've been so focused on the fact that the limit is not necessarily what the function equals, but what it's approaching. And honestly, most of the time, the value that it's approaching is what the function equals. So for example, if you just had a graph, and we want to know when it's approaching this point, almost all the time on a function, what the value's approaching is actually what the function equals. I mean, this happens like 99.9% of the time, almost always. The thing that we've been focused on, though, is like those special cases. What if the point has been removed and placed somewhere else? Or what if there was a jump in the function? And what do we do in that situation? So algebraically, if you plug in the number, and it works out and you get an answer, it's actually just right along the curve and there's no issues. It's whenever you plug in a value and you get something crazy out of it, like 5 over 0, you can't divide by 0. That's when we run into kind of these unique, interesting situations, which is really what's going on here. So what we're going to do is to calculate the limit, we're just going to use direct substitution. We're going to plug it in. And if you get a number, then that's probably the limit. That's probably it. If you get something like a number over 0, then, well, we need to go back and see kind of what situation are we in. And then we have to reevaluate and figure out what's going to happen. Or we get 0 over 0, that's also an indeterminate form. And we got to go through these other things in order to figure out what the answer is and what it's approaching. And that's because it wasn't so easy just to come up with the answer because the point's been removed, or there's a jump, or there's an asymptote. The asymptote is when it looks like this, right? And we had that vertical line, that kind of thing, or at least that's a vertical asymptote. So basically what I'm trying to say right now is the way you start with every limit is just plug in a number. If that number works, great, that's your answer, that's the limit. I mean, probably, but yes, pretty much. If you plug in the number and it works, you're done, that's your limit. It's when it doesn't work that we got to look at different situations and what we should do. So let's look at this one. This is limits by direct substitution. So we just start by plugging it in. So the limit, as x approaches 2, of x cubed minus 5x squared plus 1. All we do is just plug it in and see what happens. And I'll get 8 minus 5 times 4. Plus 1, which is 8 minus 20 plus 1, which is negative 12 plus 1, which is negative 11. So that's what the limit is. If you were to look at the graph of this function, it's approaching negative 11 as we approach 2. Same thing with this one. If we plug in a 3, it's going to work out. It's actually the rational functions we really have to look out for. That's usually when something bad is going to happen. So the limit is x approaches 3 of f of x. In this case is x squared minus 4. Over 11 minus 2x. So this is going to equal, we're just going to plug in a 3 for x, so 3 squared minus 4 over 11 minus 2 times 3. 9 minus 4 over 11 minus 6. 9 minus 4 is 5. 11 minus 6 is 5, so we get 5 over 5, which is 1. So this limit is just going to equal 1. So that's direct substitution. That's the main way to evaluate a limit. Start by just plugging it in, and that's it.